Hello everyone, this is Teacher Justina, and if you are still new to my channel, do not forget to like, share, and subscribe for more video updates. Our topic for today's video is all about derivative using the quotient rule. So what do you mean by quotient rule, or what is all about quotient rule in finding the derivative of a function? So far, when we say quotient rule, it is stated as the ratio. So when we say ratio, it's in a fractional form. Ratio of the quantity of the denominator, so quantity of the denominator, so our denominator is g of x and our numerator is f of x. So as it is stated, quantity of the denominator times the derivative of the numerator. So the derivative of the numerator, and our numerator is f of x, minus, so this is minus, so this time it's minus the numerator. So the numerator is f of x times the derivative of the denominator all over the square of the denominator. So let us answer number 1. So remember that 2 is our f of x, and the 2x to the 4 minus 5 is our g of x. So let us now follow the rule. So as it is stated that the g of x, we just copy the denominator. So we have copied the denominator as is, then times the derivative of the first function, which is the numerator. And remember that the derivative of any constant is always equal to 0. And thus, we have a multiplier 0 uh, to the denominator, to the second function, minus, so f of x is referring to our first function, so it's a 2, and times the derivative of the denominator. So the denominator is g of x, and thus our 2x to the 4 minus 5 is our uh, second function, or the denominator, in which its derivative is 8x to the power of 3. And then the denominator is 2x to the 4 minus 5 quantity square. So to further simplify, you know that any number multiplied to 0, the answer is 0. So therefore, the remaining expression in the numerator is negative 2 times 8x cubed. So we have the negative 16x cubed. And then this is squaring a binomial. And you know it already, how to square a binomial is simply square the first term. So the square of 2x to the 4 is 4x to the 8 minus twice. Twice of what? Twice of the product of the first and the second. So 2 times 5 is 10. 10x to the 4 times 2. So we have the 20x to the 4. And squaring the 5 is 25. So far, this is the derivative of our number 1. So let's proceed to number 2. So again, this is our f of x and this is our g of x. So for that, the rule says that we just copy the denominator as is. So this is our denominator times the derivative of our numerator. So 5 times 4 is 20. And then the x to the 5th minus 1 is x to the 4. And then minus 2 times 3 is 6x, and understood there is 6x to the 1, or it could be the 1 there should not be reflected because it's already understood. So minus, so f of x, so we just copy what is the numerator, 4x to the 5th minus 3x squared, times the derivative of the denominator. So the derivative of the denominator is 20x to the 4 minus 0. And our overall denominator is 4x to the 5th minus 5 to the power of 2. So far, we will now distribute the FOIL method. We have 80x to the 9, and we have the negative 24 x to the 6, because 4 times 6 is 24, x to the 5th times x to the 1 is x to the 6, and then the negative 4 times 20 is negative 80x to the 4, and the negative 4 times negative 6x to the 1 is positive 24x minus 80, that's 1, 80x to the power of 9 minus the 20x to the 4 will be now multiplied to the negative 3x squared equals negative 60x to the 6. By the way, in the denominator, you can express it into its trinomial, perfect square trinomial, or else you can just write it as is. So not unless you are instructed to expand, but it's just you can remain your denominator in this way. So let us now simplify. So the 80x to the 9, and we are just removing the parentheses, then the negative will be distributed. That is why we have the negative 80x to the 9 plus 60x to the 6. And for that, we know that they are similar terms. So therefore, we can now cancel the 80x to the 9 and this one because it gives us a 0. And so far, the negative 24x to the 6 and the 60x to the 6 are similar term, thus we can combine them. And 60 minus 24 is 36x to the 6 minus 80x to the 4 plus 24x, and then our denominator, as I've said, you can remain it as is. So this is our derivative of the given function, 4x to the 5th minus 3x squared over 4x to the 5th minus 4. Okay, so to continue, let's proceed to example number 3. So 2x plus 2 over square root of x. So we have to rewrite the square root of x into x to the 1/2. So let's now proceed to the rule g of x, so meaning our denominator is square root of x, but it is now x to the 1/2, is now being written times the derivative of our numerator, which is 2x plus 2. So our derivative is 2 minus the first function or numerator as is times the derivative of the square root of x. So the square root of x has its derivative of this one. The 1/2 will be a multiplier to x, but this time 1/2 will be subtracted by 1. So 2 over 2 is just the same thing as 1. So this is 1/2 x to the power of negative 1/2. So therefore, that is why the derivative of our g is 1/2 x to the power of negative 1/2. And then, as the rule says that we have to square the second function or the denominator. So to proceed to the next step, we have to multiply the 2 to the x to the 1/2, thus we're getting this. And then the 1/2 x to the negative 1/2 will be multiplied to 2x, thus we're able to get x to the 1/2 because we can cancel this. Okay, and there is a negative in here, that is why negative x to the 1/2. And then we have 2 times the 1/2 x to the negative 1/2. We cancel there the 2 because it answers 1. And then x to the negative 1/2. But remember, there is a negative in here. Thus, we have negative x to the negative 1/2. And then this will be denominator square. So to proceed to the next step, so it could be also written in the final step that the fractional exponent will be written into its radical expression. So instead of x to the 1/2, we have to write it to square root of x, and then minus x to the 1/2 is square root of x, then x to the negative 1/2 The x to the negative 1/2, I hope you still remember that any base raised to a negative exponent could be expressed into 1 over. The base will be copied and the negative exponent becomes positive. So that is why we have 1. This is supposed to be 1 over x to the negative 1. I'm sorry, not negative, but positive 1/2. So the x to the 1/2 is can be expressed back to square root of x. And I'm sure this is manageable. The square root of x to the power of 2 or square root of x squared will be simplified into x. So our final answer is this. Why we come up with the square root of x? Because as you have seen that we can combine the coefficient of our radical expression if and only if our radical expression are of the same index. When we say index, the root. So in here, it's also square. And our radicand are also similar. Again, we can combine the coefficients of our radical expression if they have the same index and the same radicand. So 2 minus, understood there is a 1 in there. So therefore, it's positive 1 square root of x minus this one, okay, over x. So this is our derivative for the first function. Let's proceed to number 4. So number 4, we have to rewrite the denominator as is times the derivative of our numerator. So negative 3 plus 3 times 4 is 12. Then 3 minus 1, it's x squared. Minus, we have to copy the first function as is, this one, times the derivative of our second function or our denominator. So that will be 4 will be here. So 4x and then 4 minus 1, it's a 3. And then x to the 4 to the power of 2. And for that, we can now distribute the x to the 4. So this will be negative 3x to the 4. And then that will be 12x to the 6. And the negative times negative 3x will, we have to, before simplifying the negative in there, we have to distribute the 4x cube. Thus, it gives you negative 12x to the 4 because there is a 1 in here. We add the exponents. And the 4x cube times the 4x cube will give you 16x to the 6. And now it is now our time to distribute the negative outside. Thus, the next step will be uh, rewriting the negative 3x to the 4 plus 12x to the 6, and this will become positive 12x to the 4, and the negative times positive is negative 16x to the 6 over, okay, the 4 as our inner exponent will be multiplied to the outer exponent. That is why we have the x to the 8. So therefore, we can now combine similar terms. The 12x to the 6 and the 16x to the 6 will give you a negative 4x to the 6, while the negative 3x to the 4 and the positive 12x to the 4 are similar terms. Thus, we can now combine them. So 12 minus 3 will give you positive 9x to the 4 over x to the power of 8. Okay, so I hope guys you have learned something from my video today. This has been Madam Bercoma saying goodbye and thank you everyone.